This is a summary for Unit 1, Lesson 2. And the name of this lesson is Naming the Moves. And those names are translations, rotations, and reflections. So translation is when one image, in this case image A, moves to image B, and every point in that image moves the same direction and the same distance. So here's a picture of that right here. And this is image A, it moves to image B, and each of these points move in the same direction and the same distance. So if you connect the points with line segments or arrows, those line segments or arrows will be parallel to each other because everything's moving in the same way. So here's a little animation of A being translated to B. So there goes A to B. Now when I look at these, I remember in 7th grade we studied prisms. And so a prism is nothing more than two bases, two images being translated copies of each other. So B is a translated copy of A, and B is the base of the prism, and A is on this side. You can't see it because it's covered up, but A is also a base of the prism. So they are translated copies of each other, and they are connected by each corresponding side of the polygon is connected by a parallelogram, or if it's a right prism, it's connected by a rectangle. So the bases are translated copies of each other. A rotation. So when you look at a rotation, you're going to rotate from point B to points B and C are both going to rotate. They're on the image, on the figure. They rotate the same distance. All the points on the image are going to rotate the same amount in a rotation. They're going to have a center of rotation, a point around which they rotate. In this case, it's going to be point A. So you can use a compass to measure it. You can also use grid paper. If you make these drawings in docere on grid paper, you can measure the angle of rotation by looking at the grid, so that we know that a square is 90 degrees. Going from one side of a square to the adjacent side, it's a 90-degree angle. And half that is going to be 45 degrees. Well, the diagonal of a square forms a 45-degree angle. So in this case, this side right here rotates to this side, and it rotates the diagonal of a square. So it rotates 45 degrees. So I'll measure that. It's going to be a 45-degree angle. There's point A, that's the center of rotation. There's point B. Point B is going to be on the black circle. It's going to go from this point here, this position here, to this position. It's a 45-degree rotation. C also has to rotate 45 degrees. And that's going to be on the gray circle. So if we put them on a compass, here's a compass. I'm going to put the center of the compass at A, which is the center of rotation. I'm going to line up the compass 0 degrees with this side of the image. And here's point B at the top. So that lines up with 0 degrees. So how far does point B travel? Oops. It travels 45 degrees from this point here, this position here, I should say, to this position. That is a 45-degree angle right there. C also has to rotate 45 degrees. So C begins at a position that's the 34-degree rotation. So it begins at 34 degrees right here, and it goes to 79 degrees. Well, that amount from 34 degrees to 79 degrees is a 45-degree rotation. So there's B on the black circle, and there's C on the gray circle. They're on the same image. They have to rotate the same amount. A reflection. So you're going to look for a line of reflection, a line over which the image passes or reflects to the other side. So there's the image on the left, image on the right, and that is the line of reflection. So each point moves over this line of reflection that's going to be in opposite position on the other side but a corresponding position. So it goes from this point here, reflects over. Now it's an opposite. It's the opposite direction, the opposite position, and it corresponds to this point here. So it reflects over this line of reflection to this point here. This point right here goes to this point, reflects over that line. This point reflects to this point over that line, and this point here reflects to this point over that line. So we can show that in this little animation as it reflects over that pink line, and it ends up on the other side in exactly the same position, but on the other side of the line. So you have a reflection, you have a rotation, and you have a translation.